Hello and welcome to Honors Function. In this lecture, after reviewing the terminology and notation associated with a Cartesian plane, we will review three formula. We will look at 2 points in the plane and review the slope between the 2 points, the slope of a segment, not the slope of a line, okay? We will also review the distance between the 2 points or the length of a segment. And finally, we will review the formula for the midpoint of the segment. Okay, let's start. A Cartesian plane, first of all, is a plane. This is an undefined term in mathematics. I'm not going to go over it. You should have talked about it a little bit in geometry. Now, this plane contains two real lines. A real line is a line with a coordinate system, okay? So you have a system of coordinate on a horizontal line called the x-axis, or it's also called the abscissa. 1, 2, okay? And then the negative are right here. There is a direction on this line. And there's also another, I could take the same distance for one, but I don't have to, okay? We don't have to take the same distance right here. You have a vertical line. The vertical line is called the y-axis or the ordinate, okay, axis. So this is called the quadrant 1, This is called quadrant 2, quadrant 3, and quadrant 4, okay? Quadrant 1 simply means that both x is positive and y is positive. Quadrant 2, x is negative and y is positive, and on and on and on, okay? This is called the origin right here. This point, the intersection of both lines, is called the origin of the Cartesian plane. A point in the plane, if you take a point in the plane, right here, for example, that's a point, you will associate two real numbers, its x-coordinate or its abscissa, and its y-coordinate or its ordinate. Okay? So suppose this is A and this is B. You would write the coordinate of the point as A, B. In this order, this is an ordered pair. The order matters. The first one is the x and the second one is the y. Okay, I think that was completely obvious. Let's move on to the first formula. Again, this is a review. So I'm taking my Cartesian plane right here. Right that. I'm taking 2 points in the plane. So for example, here I have a point that I'm going to call A. And that's going to be x sub A. I usually write subscript notation like that, and y sub A. And then I'm going to take a second point right here, calling this point B, with coordinate, of course, xb and yb. xb and yb. Okay. Then I have a segment. I have a segment right here, whose endpoints are AB. Now I will look at three formula related to the segment. The first one is the slope of the segment, so the slope of the segment, slope of AB. So slope, you know, we write it as m, and slope of AB, if I do deal with segment, I will use my geometrical notation. This is a subscript. What is the slope of the segment AB? Well, for the slope in math, this is nothing new. You know, we look at this distance right here, this algebraic distance. It has a sign, right? And we look at this one. This is called the run. It's on the horizontal line, while this is called the rise, okay? So the run is xb minus xa, okay? xb minus xa, and the rise is yb minus ya. You take the second point first and you subtract the coordinate of the first point. And we define the slope to be the rise over the run, so it's yb minus ya equals xb minus xa, okay? Now, you could also multiply the numerator and the denominator of this fraction by -1. Therefore, you would have ya minus yb over xa minus xb. What really matters in this formula is that you start with the same point at the denominator and the numerator, okay? That's all. So this is a very old concept. I'm not going to go over which segment is steeper than the other, what's an horizontal segment, what's a vertical segment. I think I have a few examples. You should be completely fine. I'm going to assume in this case that you do remember what the slope of a segment represents. Be careful, we haven't yet defined the slope of a line. Let's do one or two examples. Okay, I'll be nice this time. I will take number 1, which is probably the most tedious. Let's get the slope of this segment. They all have rational numbers. So the slope of the segment is going to be 1/2. I'm talking about this one right here, right? 1/2 minus 5/3, 1/2 minus 5/3, divided by negative 2/3, negative 2/3, plus, okay, minus negative 1/2 is plus 1/2. Now, listen up. Actually, I'm taking this one because I want to show you something. You will see me do that pretty often. I am not going to get a common denominator here. Instead, what I'm going to do, because I'm lazy and it's faster, I'm going to multiply both sides of this fraction by the common denominator. So here it is 6, and it's going to simplify everything. Now be careful when you distribute, okay? All right. So what do we have? 6 times 1/2 is 3, minus here the 6 and the 1/3 will divide, and you're going to have a 2 left right here, right? 2 and 1 right here, right? So it's minus 10 over here the 6 and the 3 will simplify, and you're going to have a 2. 2 times negative 2 is negative 4. And then, got to be careful here, the 6 and the 2 will simplify, but now you'll have a 3. Here we go. You see, it takes a little bit of practice, but it's so easy. So on top, it's negative 7, and on the bottom is negative 1. Oh, check it out. So it's also 7 over 1. Now, this means, concretely, what does it mean? Negative 7 over negative 1, it means that you go down 7, you drop 7, and negative 1 means you move left by 1 unit, okay? So here it is. That's the slope of the segment. And if you really like that, what does it mean? It means you go up 7, okay, the rise is 7, and you move right 1 unit. And these two segments, of course, this one and this one, have to be parallel, all right? Okay, I'm going to let you do number 2 and number 3. Let's go over the distance between the 2 points or the length of a segment. So here is what I start with. Cartesian plane and 2 points in the plane and the segment AB. So I want to find the distance between the point AB. This is how we write it in algebra, but you also know that in geometry we write this simply as AB, and we don't put anything on top because that would be the set of points, okay? Well, this is a real number. It's the length of the segment AB. So this is what I want. You're gonna have to remember all this formula, okay, today. So how do we do that? Well, we use the Pythagorean theorem. We build a right triangle right here. Okay, we build the right triangle right here, and let's use the Pythagorean theorem. So we're gonna call this point C, okay? And I'm gonna say that AB squared equals AC squared plus CB squared. Now AC squared, this length right here, is congruent to this one right here. It's congruent to this, let me take the thick one. Is congruent to this length right here, okay? Same length. While BC squared, this one right there, is congruent to this length right here, okay? Now we have defined the distance between 2 points on a real line, okay? So AC squared is the same thing as the absolute value of XB minus XA, right here, the first one, right? XB minus XA squared plus CB, I'm talking about this one now, okay? And this is the absolute value. We've done that in some set of note before. I think it was in absolute value. YB minus YA squared, okay? Now, there's a property of absolute value that says that if you take number square, the absolute value of a number square, it's the same as just taking the number square, okay? Because the absolute value, the square and the absolute value are redundant here. So what do I have? I have XB minus XA squared plus YB minus YA squared. But this is not AB, it's AB squared. Therefore, the distance formula is AB equals square root of XB minus XA squared plus YB minus YA squared. Okay? Now, in this formula, it doesn't matter what you start with in any of the two parentheses, because we know that XB minus XA squared is going to be the same as XA minus XB squared. So it doesn't matter what I start with. If I'm squaring, the relation between these two quantities is that they are opposite of each other. And if I'm squaring two opposite numbers, I will find the same output. Okay, let's go over some problems. Okay, I'm gonna let you do the easy one, 4 and 5, and for a change, I'm gonna do the more difficult, number 6 right here. So what's going on in number 6? And if you want to try, just pause the video and try it on your own, okay? What's going on with number 6? I want to find all the points with a coordinate, I'm sorry here, I meant with x coordinate 1, which are the points, which are 4 units from the point 3, 2. So I don't need to draw anything here, but I'm going to, just to show you, to have an idea of what's going on. Here is the system of axes, right here. My points that I'm looking for have an x coordinate of 1. So here's 1 right here. My points will be on this line, okay? If they have an x coordinate of 1, they're going to be on this line. All right. What do I want about them? I want them to be 4 units from 3, 2. Where's 3, 2? So 2, 3, and let's say 2 is right here. So 3, 2 is about here, right here, okay? And I want to be on the blue line 4 units from this point right here. So actually, I don't have enough room right here, but this is 2 units. So 4 units would be like this right here, right? So I'm going to have to use this length right here. And I'll place it here, right here. You see, that's about 4 units right there. So I will have 1 point here. And there will be another one somewhere up there, right? So you see, I'm looking for, I should find 2 points, okay? All right, let's now do the problem algebraically. The point that I'm looking for, they have an x coordinate of 1, so I'm going to call that 1 and y, right? And there are 4 units, so I know the distance. So d, the distance, let's call the distance d. D is 4. I don't want to deal with square roots. That means that d squared is 16. Let me write the distance formula. 16 equals the distance between this point and this point. So it is 3 minus 1 squared plus y minus 2 squared. And you see now this is a pretty simple equation to solve. So this is 3 minus 1, 2, 2 squared, 4. 16 minus 4, 12. 12 equals y minus 2 squared. Now, how would you solve that? Please do not expand, right? You're going to be wasting time. It's already solved for a square right here. So I have y minus 2 equals plus or minus square root of 12. Let's simplify this square root of 12. Plus or minus 2 root 3. And so y is equal to 2 plus or minus 2 root 3. Make sure you answer the question. The question was to find all the points, right? So I need to write coordinate of the points. So therefore my points are 1, 2 plus or minus 2 root 3. That's it. Okay, I'm going to let you do the example 4, 5, and 7 in this series of example. Let me go with the last formula of this set of notes. Here again, I need the Cartesian plane and the segment. The last formula is about the midpoint. This is actually a geometric definition, the midpoint right here. We would say that M is the midpoint of the segment AB if and only if the segment AM is congruent to the segment MP. Now, if you use this definition, you can prove, therefore, it shouldn't be called a definition, you can prove that the coordinate of the point M are the average of the x's, xa plus xb over 2, and the average of the y's, ya plus yb over 2, okay? This is the coordinate of this point right here. We could prove this, so it should not be called, as I did in my set of notes, a definition, but I'm choosing the easy way out, and I don't want to have to prove that. It's really not difficult. I just don't want to have to do it, okay? All right, let me do one example, and you do the next one, and we're done with this very short set of notes. So midpoint of the segment, well, hey, average of the x's, average of the y's. 9 plus 6, 15. 15 by 2, 7.5. 5 minus 1, 4. 4 by 2, 2. That's it. This is the coordinate of the point. Thank you for watching.